All right, today we go through lesson 27B, proportional relationships with graphs. Yesterday, we talked about how to determine if something had a proportional relationship from a table. And assuming that you remember how to plot or graph ordered pairs from 6th grade, today would actually be easier. I found out last period, though, that too many people didn't know how to plot ordered pairs from 6th grade. So you'll need to make sure that when I'm quickly reviewing that, you recall how to do that, because that's something that's very, very simple. So today our focus is on determining if a proportional relationship exists in a graph, and we're also going to talk about how to find the constant of proportionality from a graph. So we did those same things yesterday, but from tables, from graphs, it is easier. Okay? So background knowledge, yesterday we reviewed that earlier in the year we talked about how to determine if something was proportional by checking two ratios, and if the ratios are equivalent, we have a proportion. If they're not, like in the first one, then we don't have a proportional situation. So go ahead and fill in something in your notes there. A proportion, and this is the third time I've actually talked about this definition. A proportion is an equality between two ratios. And then yesterday we added to this the definition of a proportional relationship. And we have a proportional relationship when we have a collection of ordered pairs, or a collection of pairs of numbers that form equivalent ratios. And that's how we checked yesterday from our table. We checked ratios of y over x, and if they were all equivalent, we had a proportional relationship, and whatever they were all ended up simplifying to, that ended up being our constant of proportionality. Well, today we take this to graphing. But before we even do that, I've got to quickly review how to plot ordered pairs. Okay. So, do you recall how to graph ordered pairs in the coordinate plane from 5th and 6th grade? Well, we're going to find out. Since we are restricting our graphing right now to one quadrant, quadrant number 1, which last year you were supposed to talk about quadrants, we are simply going to start at what's called the origin. So we start at 0, 0, and then from there we're either going to go right, and then we're going to go in the upward direction. So all ordered pairs look like that. Some number, comma, some number. And they're usually given as in the form x, comma, y. You should write this stuff down somewhere off to the side. I know that's not a spot where you have to fill in blank areas, but you should write this down somewhere. So ordered pairs are given in the form x, comma, y. And since we're restricted to the first quadrant, we're going to go right, and then we're going to go up. Okay, so we always start at 0, 0. So the first ordered pair, and I went ahead and I plotted 0, 0, and I know that I believe that's already plotted for you. But if I wanted to plot 5, 3, here's where you need to listen if you don't remember from 6th grade. This means that you are going to go right 5, and then you're going to go in the upward direction 3. So you would go to the right 5, and then you would go up 3, and right there is where we would plot 5, 3. So right 5, up 3 is right there. If I wanted to plot 10, 6, that would be 10 to the right and 6 up. Who can describe for me how we would plot 15, 9? Go ahead.
You would go all the way to the 15 on the bottom on the x.
Well, which direction?
Oh, right.
Go right 15, yeah.
And then you would go up to the number 9.
Okay, there we go. So right 15, up 9, which is right there. And like I said, these are all already plotted for you in your notes because we're going to use those in just a second. So that's a quick review on how to plot ordered pairs. Go right, whatever the first number is, then go up, whatever the second number is, because we are restricting this to the first quadrant. Okay. And then here's what we did yesterday. Here was a table from yesterday. I forget which problem number it was, but we were comparing the height of bamboo to the number of days that it grows. And we first checked to see if it was a proportional relationship by checking all of the ratios, y over x. And we talked about the fact that we needed to make sure we used y over x for many reasons, but one is because it gives us the constant of proportionality. So when I check all these ratios, they are equivalent. They are all equal to 60, and that 60 is the constant part of our unit rate, and it's referred to as the constant of proportionality. And we use the letter K to simplify that or write that. So we use that variable so we don't have to write the words constant of proportionality. So K is equal to 60. That is the constant of proportionality. Do we all remember that from yesterday? Yes or no?
Yes.
Okay. And then that will lead us also to the unit rate of 60 centimeters per day. Okay, bamboo grows at 60 centimeters per day. All right, so let's go to the official number one. Well, what if you don't have a table like we had yesterday? What if you have a graph instead? Now, this is the second time that I've said this. Dealing with graphs is easier as far as determining if it's proportional and finding the constant of proportionality than a table is. Way easier. But it's only easier if you understand and listen to what you are supposed to do. Okay? So here's that graph that we had when we were reviewing the plotting of the ordered pairs. And here's where you need to start filling in some things in your notes. Graphs that have a proportional relationship are always lines and always go through the point 0, 0. So I'm going to stop for a second to let people get caught up. Okay, so this graph is in your notes. Let's go through those two questions. Is this a line? Yes or no? Yes. Yeah, that's not a trick question. It is a line. Okay, so that's good. Then the next question is, does it go through 0, 0? Yes or no? Yes, yes it does. 0, 0 is this point right here. It's the origin. We call that the origin. If you want to think of it as the corner in your first quadrant, you can think of it that way too. But since this is a line, and we'll put a definition to that in just a second, and since it goes through 0, 0, and we'll put a definition to that in just a second, that means that this is a proportional relationship. So the graph does have a proportional relationship. If we have a line, if it goes through 0, 0 from your graph, or by looking at your graph, we have a proportional relationship. Okay? All right. So let's put a definition to lines and put a definition to 0, 0. Here's where you have something to fill in again in your notes. A linear graph is a graph that is a line. So from now on, you're going to hear me say, is it linear? What I mean by that is your graph a line? And then the definition for 0, 0 is the origin. So I will say to you, does it go through the origin? What that means is, does it go through 0, 0? Okay? So you're going to hear me now use those terms linear and origin instead of is it a line or does it go through 0, 0. And I notice a few of you you're not putting parentheses around your 0, 0. That's what makes it an ordered pair when you put parentheses around it. Make sure that you do that. All right, let's go to number 2. Number 2, here is your graph. I want you to answer the questions for number 2. All right, questions for you. Is the graph linear, yes or no? Yes. Yes, it is. Does the graph go through the origin, yes or no? No. No, it does not. And the reason why you can tell that is because the origin is right here. That graph does not go through the origin. It looks like the first ordered pair there is actually 0, 3 because that ordered pair is 0, 3 because you're not going right, but you are going up. So you're going right 0 places and up 3. It's not 0, 0. It's not the origin. So that alone tells us whether this is a proportional relationship or not. Is this a proportional relationship, yes or no? No. It has to be yes for both of those questions. Linear and going through the origin. All right, are we clear on how to determine from a graph?
Yeah.
That's what I'm saying, that it's easier. It should be easier. It should seem easier to you. All right, let's flip to the back side of that in our notes. Let's go ahead and do the same exact thing for number 3. I'll give you about 1 minute to answer all parts of number 3. We are asking ourselves 2 questions. We're asking ourselves if it's linear. Look, somebody last period thought because all the dots were connected together, that meant linear. No, it doesn't. If it curves at all, it's not linear. Linear means a perfectly straight line. Is this graph linear? No, you can stop right there. It's not a proportional relationship, okay? I know it goes through the origin, but it doesn't matter. If it's already no for the question of whether it's linear or not, it's not a proportional relationship, and that's why I didn't even bother answering, does the line go through the origin? Because it's not a line, and it does go through the origin, but it's not a line. All right, so that should seem fairly simple. Now we're going to kind of link the 2 things together. So in number 1, we now have restarted the numbering simply because we're going on to a different idea here. But here we are comparing the price of a different number of books. So 1 book costs $4, 2 books cost $7, 4 books cost $13. Here's what I want you to do. The first thing I want you to realize is that when we write ordered pairs, we write them in the form x, comma, y. And you may want to write that down again. And so what that means is from these 2 numbers right here, 1 book costing $4, that gives us an ordered pair, 1, comma, 4. 2 books costing $7, that gives us an ordered pair, 2, comma, 7. And 4 books costing $13, this gives us a third ordered pair of 4, comma, 13. You have a blank coordinate plane. I want you to go ahead and plot all 3 of those ordered pairs. Then, this is why you have your ruler. Neatly draw a line all the way through the ordered pairs and all the way through the coordinate plane, and then answer the question. Is it a proportional relationship? Okay, I'll give you about 45 seconds to do that. All right, so when you got together with your shoulder partner, I did hear the majority of you say, no, it's not a proportional relationship. I'm going to add some things in here on this problem, and I want you to add these to your notes, because it does say there could also check the ratios. And we're going to link what we did yesterday to this one. So if I plot these ordered pairs, here's a perfect graph of what this looks like. And some of you, your graphs were a little sloppy, and I even borrowed your paper, and my pencil was not very sharp, so it was really hard to tell. So sometimes from a graph, it might be hard for you to tell whether it goes through the origin or not. And this might be one of them. But if you look at my graph carefully, is my graph going through the origin? Yes or no? No, it's not. From your graph, it might be hard to tell. So what are you going to do if it's hard to tell? Well, I'm telling you right now it's not a proportional relationship. But here's what you could do if you're not sure. And I want you to add this to your notes. Right below where it says could also check the ratios. So what we're going to do is we're going to do what we did yesterday. And I'm going to prove to you that this is not going to go through the origin. Check our ratios of y over x. Our first y is 4. Our first x is 1. That's 4 over 1, which is 4. You should be writing these down. All I'm doing is I'm doing what we did yesterday. From those 2 numbers, from those 2, and those 2. And remember, we have to check with y over x. Our second one is 7 for y and 2 for x. That, guess what, is not 4. We could stop with the ratios. If the ratios are equivalent, it's a proportional relationship. But these ratios are not equivalent. Therefore, it's not a proportional relationship. So I've shown you with a graph that's not going through the origin, and I've proven it to you by checking the ratios of y over x. It's not a proportional relationship. Okay? All right, I want everybody to do exactly the same thing, all parts that I just did for number 2. I want you to plot your ordered pairs. I want you to use your ruler to neatly draw a line through them all the way through the coordinate plane. Then answer yes or no as to whether it is a proportional relationship or not, and then verify it with your ratios. All right, so let's plot those. We have 3, 2, 3 to the right, 2 up, 12, 8, 12 to the right, 8 up, 15, 10, 15 to the right, 10 up. Neatly draw our line all the way through the coordinate plane. We can see it's linear and it goes through the origin. So that means that it's a proportional relationship. We verify it with our ratios. So we have y over x, we have 2 over 3. That's already simplified. We have 8 over 12, that simplifies to 2/3. And we also have 10 over 15, that also simplifies to 2/3. And remember from yesterday, that means it's a proportional relationship, and the constant of proportionality, k, is equal to 2/3. All right, let's go to the next problem. The next problem, the table got left off. So look up here for the table. Same thing. Plot your ordered pairs, determine whether it's a proportional relationship or not. And once again, that's the table you should be using. So we plot 1, 4, and 2, 8, and 3, 12, and 5, I went backwards, sorry about that, and 5, 20. And draw our line all the way through. We can see we have a line, it's linear, and it goes through the origin. And that means it's a proportional relationship. So now the next question in your notes was, what's the constant of proportionality? And I walked around and I saw everybody was going, all right, 4 over 1, and 8 over 2, and 12 over 3, and 20 over 5, because that's the way we did it yesterday. So what's the constant of proportionality? Just say it. It's 4. So k is equal to 4. But how are you going to find the constant of proportionality if I didn't give you a table? In other words, what if that's not even there? And all I gave you was the graph. How in the world are you going to find the constant of proportionality? Well, it's actually very simple. It's found on your graph. It's found, and I'd like all of you to make a little note in your notes, it's found right here at this ordered pair. That ordered pair on a graph is extremely important because that ordered pair is 1, some number. And that number right there is the constant of proportionality on a graph that is a proportional relationship. So notice that that ordered pair is 1, 4. And 4 happened to be the constant of proportionality. So let's fill in some things on our notes that sort of summarizes that. All right. If all the ratios from a table, and this is where you need to start filling some stuff in. If all the ratios from a table are simplified and equivalent, that ratio is the unit rate or the constant of proportionality. We talked about that yesterday. All right, let's continue on here. Where will you find the constant of proportionality on a graph? Well, I kind of just explained that. You will find it on the ordered pair 1, something. 1, something. And since we use the letter k for the constant of proportionality, it's at the ordered pair 1, k. And remember from yesterday, k is the variable we usually use for the constant of proportionality. So that's the important ordered pair that we're looking for. 1, some number. So let's now go to the next problem. And I already talked about that. All right, here's number 4. Go ahead and quickly plot all 3 of those ordered pairs and answer the questions if you can. So the first thing that I'm asking you is, do the numbers in the table represent a proportional relationship? Does it look like they do? Yes or no?
Yes.
It looks like they do. So let's go ahead and plot those. 2, 5, 4, 10, 5, 12.5. It is linear and it goes through the origin. So that is a proportional relationship. But the next question is this. If so, what is the constant of proportionality? And I noticed as I walked around, a lot of you were kind of stuck, and so you went back to checking ratios. If you can't tell from your graph, then that's what you should do. And the 1 comma something on this graph, it's kind of hard to tell. But it is there. It happens to be right here. There's just not a dot there. But if you can't really tell from your graph, well, then that's when you want to go back to checking your ratios. So you check by using your ratios of y over x, which that's 2.5, that's 2.5, and that's 2.5. So that means that our constant of proportionality is 2.5. Now, why did I go with 2.5 instead of 5 halves? Because that last one, we had to use 2.5. But 2.5 and 5 halves represent the same thing. So our ratios are equivalent. K is equal to 2.5. Go ahead and fill that in. And once again, our line goes through the origin, and our ratios are equivalent. So let's do a little bit more investigating on if you have a graph and if you don't have a table, how you're going to find the constant of proportionality. So let's go to the back side of the second page of your notes, and everybody look at the first graph. Is this the graph right here? Yes? Okay. Look at the graph. The question is only this. It obviously is a proportional relationship. It's linear and goes through the origin. The question, though, is what is the constant of proportionality? Turn to your shoulder partner and talk about what you think the constant of proportionality is. Let's look at that. Angel gave us that ordered pair right there, 1, 6. But 1, 6 is not the constant of proportionality. Remember, from a ordered pair, it's the second value, the y value, which we use the letter K to represent the constant of proportionality. And so go ahead and fill that in. That means our constant of proportionality is K equals 6. Do we see how easy that is from a graph? Yes or no? Yes. All right. But what if there's not a dot on 1, something? Well, sometimes we are given a graph like that, and it looks like this. The constant of proportionality is there. Let's see if you can figure out what it is. Take a look at it. And then I'm going to have you turn to your shoulder partner and talk about what you think it is from this graph. Let's talk for a second about why it is K equals 3. If you didn't get that, look. There is an ordered pair right there. We just don't have a dot. So let's go over to 1 and then up. And if we go up, we have an ordered pair right there. Fill it in if you didn't understand that. It's a perfect ordered pair, and that ordered pair is 1, 3. And remember, it is that 3 right there that gives us our constant of proportionality. So our constant of proportionality is K equals 3. And sometimes that's what we have to do straight from a graph to figure that out. So K is equal to 3 for our constant of proportionality. All right, we are finished.